Hi, welcome back to Math 111. We're going to spend a few minutes, this one should be pretty short, talking about absolute value functions. There we go. We kind of all sort of know what the absolute value is, but let's look at the formal definition. Probably the definition that you've used before is that the absolute value of x is the distance from the real number x to 0 on a number line. So for example, the absolute value of 5 is 5 because it's 5 units from 0 to 5, and the absolute value of -5 is 5 because it's 5 units from -5 to 0. But let's take a look at the formal mathematical definition of absolute value. So the formal mathematical definition is that we define the absolute value of x as a piecewise function. And we say that the absolute value of x is just equal to x if that number x is greater than or equal to 0. And that the absolute value of x is equal to the opposite of x if that x value is less than 0. So, for example, if we shove in x -5, and we take the absolute value of -5, the negative of -5 is 5, which makes sense because we know that the absolute value of -5 is 5. So let's talk about some rules for absolute value. These are rules for manipulating the absolute values. If you've got the absolute value of a product, say it's the absolute value of A times B, that's the absolute value of A times the absolute value of B. So for example, if we were taking the absolute value of -3x, or -3 times 2, this is a grouping symbol. We could multiply -3 times 2 to get -6, and we would know that that absolute value of -6 is 6. Or we could take the absolute value of -3, which is 3, and multiply that by the absolute value of 2, which is 2. 3 times 2 is 6. Either way, we're going to get +6. Exponents are just repeated multiplication, so it makes sense that we can take an exponent outside of an absolute value. We can also take division outside of the absolute value. Be careful with addition and subtraction, though. Because this is a grouping symbol, we need to do the addition and subtraction inside. We cannot just pop them out. That's not the same thing. So what I'm saying is, be very careful that you realize that the absolute value of A plus B does not equal absolute value of A plus the absolute value of B. It might, but it might not. Because remember what this means. The absolute value of A plus B is defined to be A plus B if the quantity A plus B is greater than or equal to 0. But if that quantity is negative, then it is the opposite of that, right? So what I'm saying is, don't do that. That's not okay. You can do this, and this, and that. You can't do that with addition and subtraction. Okay. What else do we know? Oh, let's talk about absolute value equations. If you've got absolute value of x equals some number bigger than 0, like the absolute value of x equals 3. Well, the solution to that, there are two numbers who have an absolute value of 3. So x will equal 3, or x will equal negative 3. If you've got something like absolute value of x equals negative 7, there is no solution to this one, because absolute values are always greater than 0. So let's do some graphing. For today, I'm going to do this on my TI, just in case there are a couple of you who are using TIs. You can absolutely do these either by hand or with Desmos. We know what the absolute value function looks like when we graph it. We have done that. So on a TI, let's see, go into your y equals button, clear out anything you have there. And to find the absolute value, what you're going to do is you're going to push the math key. Then you're going to arrow over to the NUM, and right there is absolute value, so just click enter. And now we'll just type in what we want, so x. And we're going to graph this first one. We know what it's going to look like, right? We know it's going to do that. I'll just graph it. Sure enough. So this is what we expect. Based on our definition, we said that the absolute value of x is equal to negative x, which is a line with slope -1, if x is less than 0, and positive x if x is greater than 0. So this is what we get. What's this going to do? What is this -3 on the inside going to give us? Well, let's take a look. Let's just put it down here. I'm hoping you know, but if you don't, this will hopefully remind you. We know it's going to be a horizontal shift. Which way? Yeah. Always feels backwards, right? This is going to be towards the positive x-axis. And sure enough, there it comes. So this one is the original absolute value x. This one is the shifted. This is number 2. So this guy looks like that. This one, this is going to be a vertical shift. So that's going to look like that. And let's look at the last one here. So what do we have here? We've got a horizontal shift of 1, a horizontal stretch of 3, a vertical stretch of 2. The thing is turned upside down, and we have a vertical shift of 4. So if we graph that, we should expect an upside down V with its center at, or its peak at -1, 4, and then it's going to be steeper. Let's see what happens. So there's my standard one. And yep, there's my upside down one. So we've got, let's zoom in so that we can see. My Zoom didn't work. Okay. Change my window. We'll go to -5, -10. We'll try -10 to 10 and graph. Let's try -5 to 5. That's better. So we can see that sure enough, my peak is offset a little bit from my standard one. Other than that, it looks like an absolute value. So let's switch over to Desmos, just because Desmos is easier to see. And let's talk about just this last one. We're going to do all of this stuff for just this last one because it's the most interesting. So we're going to graph y equals 4 minus 2 times the absolute value of 3x plus 1. Okay. So what is the domain? Well, I can plug in any number, right? So my domain is -infinity to infinity. What's my range? Well, that's -infinity up to what? 4. Can't get anything bigger than 4, but I can get 4, so I use a square bracket. All right, where is it, this thing increasing? -infinity up to 4, and decreasing 4 to positive infinity, right? Oh, there you go. Here's your graph. Sorry. Whoops. So there's our graph. You can see the domain. I can plug in anything I want. You can see the range. You can see the increasing and the decreasing. What's the extrema? Yeah, we've got a maximum right here. So yes, we have a max at y equals 4, or that is the point -1/3, 4. All right, nothing too surprising, yes? Okay. This is why I suggested we get really comfortable with transformations. All right, and here is your solution. All of them. This is more of the same. The interesting one, so let's take a look at how we're going to handle these. Because our calculators can actually handle absolute value, these get a lot simpler. This one, what do you think we're going to have here? So think about this in terms of two cases. If x is less than 0, what is the absolute value of x? It's -x, right? Which is just -1 if x is less than 0. What if x is positive? Well, then it's just x over x, which is 1, if x is greater than or equal to 0. So what we are expecting to see when we graph this is two horizontal lines. Let's see. Sure enough, there they are. So, what's the domain? Yeah, this one's a little tricky. What can I not ever plug in here? I can't divide by 0, can I? So my domain oops, sorry. Computer's being a little finicky today. It's not behaving itself. What's my domain? My domain is everything except for 0, right? So my domain on this first one is negative infinity up to but not including 0, unioned with 0 to infinity. All right. This one I'm going to leave for you to graph. It's pretty simple. Just plug it into your calculator or use Desmos. So that's pretty much it. This is what you should be able to get on both of these, and that is it on absolute value. Have a great day.